Okay, so this is the last FRQ from the AP Chem exam 2025. And part A asks to circle the atom that accepts the protons when this ion reacts with water. So if we look at the structure here, oh, this is thick. This should be the one that accepts the proton, because in order to make, like this right now is a base, and it's willing to accept the protons, and as an acid it would be like this, and it would have an organic a carboxylic acid functional group, so like this, and it just needs the H on here to complete this situation. So yeah, the answer would be this O, this oxygen right there. At 25 degrees Celsius, 2.5 molar solution is found to have an OH concentration. To calculate the value of Kb. Okay, so what I did here was, I sped this up, but what I did was just a quick ice table. Since they give you both the final and initial, it's pretty straightforward. I just wrote this out here because the top is just the concentration of the HC2H3O3 times the concentration of hydroxide ions. And since they have the same stoichiometric ratios, it's the same amount, like the same concentration for both of them. So that's why I just did like squared, because it gives you the concentration of the hydroxide up there, right? So it's pretty straightforward. And then for the denominator, we have the glycolate ion, and its initial concentration was 2.5. And since it reacted to form the hydroxide and the glycolic acid, it's subtracting the change from its original value. This is the OG, this is the change. So if you plug this into your calculator, okay, so I got Kb is 6.76 times 10 to the negative 11. So gives you 2. So I guess you can round to 6.8. But it also doesn't ask to round, so I guess you don't have to. What you could have also done here was you could have assumed that the change was small enough that it was negligible, so you can use the 5% rule and just ignore this change. Negligible. Okay. But you would just have to show that the change is less than 5% of the OG, which we know it is, because 1.3 times 10 to the negative 5 is less than 5% of 2.5. 5% of 2.5 is what, 0.125. So yeah. Anyways, this is the Kb. And then, oh, it always does that. This is so weird. The second part says, using the answer to part B1, calculate the value of Ka. Okay, so we know that at 25 degrees Celsius, Ka times Kb equals 1.0 times 10 to the negative 14. So with some manipulation here, we get that K equals 1.0 times 10 to the negative 14 divided by Kb. So Ka here would be, I got 1.47 times 10 to the negative 4. And you can also round that just to 1.5 times 10 to the negative 4. And then the last part, a student claims that H3O is a catalyst for the reaction. Do you agree or disagree? Justify your answer based on the mechanism given. Okay, so in order for something to be, like, I guess considered a catalyst, it has to be, it can be consumed, and it can't be changed. So let's just see here. This is the first step of the reaction, and then the next time we see hydronium is here. So it appears in the beginning and it appears again in the end. So we can say that we agree with the student's claim. Okay, so this part I definitely wrote too much for, but basically the point is it's not consumed in the reaction. It starts off as a reactant and it comes back out as a product. So we can tell, like, just by the fact that it does not participate in the reaction, from that we can tell that the hydronium was a catalyst. Okay, so yeah, this is pretty cool. Have fun studying and good luck on the AP exam.